Hi everyone, this is Jared Friedland. We're going to be going over strategies for teaching your students the math portion of the SAT. I know that a lot of you who are new trainees might have the sort of the most apprehension about the math portion of this boot camp. So I'm going to go pretty slowly and make sure that I explain really fully how to do every single type of question that's in this book and also address some of the more common questions that you'll probably field from students. Before we dive in, just a couple of important notes here. So most of you again will be teaching boot camps that occur on the weekend. There are some boot camps that we do that take place during the week or later on the weekend, meaning later in the day. But most of you will be teaching from 9 a.m. to 1 p.m. both Saturday and Sunday. Assuming that you fall into that category, you always want to remember to get there at 8:30 sharp, begin setting up the room. Usually what we hear from our gurus is that they're a lot more relaxed on day two because they've already been through day one, they've gotten to know their students, etc. But make sure you arrive by 8:30 sharp so you can begin setting up and welcome students as they're coming in. Um, Same real setup for day one, where as students are coming in, you want to be friendly with them, ask them, when they're taking the SAT, try to get to know their names. And I would particularly try to engage with students who maybe weren't that participatory during day one. Really try to get them to be more lively on day two. As always, there may be a faculty member or a parent representative who's in the room or nearby. Please, please, please make sure that you are being really friendly with that individual. They do a lot for us. Some of them, if they're on a PTA, or volunteers, and they're there just to help the students. So please be sure to be friendly and professional and thank them and make them feel good about the program. Um, One more thing before we really dive in here, which is this is more of a macro note for all of the math. I would say in almost every single class, you'll have a couple of students who are really advanced at the math. You'll have the great majority of students who are somewhere in the middle, and then you'll have a couple or a handful of students who may be in more foundational or remedial math classes. The math can be among the trickiest portions of the SAT boot camp, in part because it tends to really segment students quite a bit, like stratifies the room. So one way that you can deal with that is you want to make sure that you're really speaking to all groups of students. If you think that you're doing something that or explaining a concept that maybe some students who are more advanced might be inclined to think, why am I doing this? I already know this. A simple way to acknowledge that is just to preface it by saying, I realize some of you may have done this before. I just want to make sure if you've done this in previous years, you may need to dust this concept off to do well on the SAT. And the fact of the matter is that's true. Sometimes you'll have students who are really gifted at math who might be heading toward Caltech or MIT or Carnegie Mellon and for engineering, and they get their score back and they get like a 750, God forbid, out of 800. And it's not that they can't. It's actually probably the easier or the more medium questions that trip them up because they might have forgotten things like slope or the quadratic formula, or factoring and foiling, the difference between like an integer and a non-integer. So remember, if you want to try to speak to all different groups in the room, and then in terms of the students who struggle more with math, you can acknowledge that if you see their facial expressions and they look confused, you can say, listen, I realize that you might be a little bit, some of this might be a little bit confusing for you. That's okay. First of all, remember, in this book, after every single problem that we're doing is a step-by-step process. And that's there for you so that if during the course of this, if you're not quite sure how to do something, I'm going to do my best to get to questions, but you can always go back and reread that and check out our step-by-step process on your own. In addition to that, you can always call our office and we'd be more than happy to help you. And you can always write that number on the board. And that number is this, which is also on the back cover of their books. Or you can email us at info@catalystprep.com. One more note before we dive in. Again, this is for all of you gurus. Sometimes in a math class, you'll have like one, really gifted math student. More often than not, this particular type of student tends to be someone who, I've said this in training sessions, it's almost like they're trying to show off. They're like flaunting their plumage in front of the other students. So what they'll do is they'll start raising their hand and saying, couldn't you also do this question using such and such theorem? And that student knows full well that the answer to that question is yes. What he or she is really doing, again, is sort of flaunting the plumage and trying to prove to all the other students in the room, hey, look at me. I'm really advanced in math. I know this esoteric formula or theory or what have you. That's all well and good. Again, we don't want to really call that student out, but what you can say is this: if you have a student like that, or a student who says, well, couldn't you do this one algebraically? Your go-to response to that, because you may well have that, is you're absolutely right. There are multiple ways to do a lot of questions on the SAT for the math. Remember, this is a standardized test. The Scantron, the machine that's going to be grading your bubble sheet, doesn't know whether you're a math genius or you're just a really good guesser. All they know is whether you got the right answer or the wrong answer. So the bottom line is there are multiple ways to do each problem. If you have a way that works for you that might be more comfortable for you or more efficient, then you know what? Go for it. My purpose in stating these strategies is to make absolutely sure, though, that when you look at these problems, particularly the problems that tend to stump students, that you don't think to yourself, how do I even get going here? I don't even know where to begin. I want to make sure that you at least have one method for cracking these problems. But yes, they can be done in multiple ways. So that's a way to basically acknowledge that student without having to really call that student out on, on essentially showing off. All right, so you'll dive in, you'll warm up students. You want to start off with the oath, which is mirroring the way that you started on day one. Students get really into this again. It's something that they find that it really does, again, like elevate the energy and the mood in the classroom. So you'll walk students through this. Again, just a reminder, this is a call and response activity. So you'll say, I, class says, I, teenage American sitting in this class right now, teenage American sitting in this class right now, so forth and so on, through the bottom of page 249 here, okay? And again, students will usually find this pretty funny and enjoyable. And in fact, as I did in the other videos, I will do a cutaway now, and you can see how this oath worked in a boot camp that I led, again, in Austin, Texas. All right, so let's cut away to that now. So I, the teenage American sitting in this class right now, I'm going to do math for the next 2 hours of my life. Oh my God, please tell me this SAT person didn't just say 2 hours. Oh my God, please tell me this SAT person didn't just say 2 hours. And even though there are a lot of other things I'd rather be doing right now. Like going to movies. Or sitting at home. Or undergoing dental surgery. Without anesthesia. I'm going to pay attention. For the next 2 hours. Oh no, the SAT person did say 2 hours. Because I want to get a really high score on the math portion of the SAT. So I never, never ever have to look at another italicized X or Y the rest of my life. Okay, thank you guys. Okay, so now that you saw that, and you saw that students did have a good time with it, and remember, those kids were not generally the most, it wasn't the most lively group. It was probably one of the least lively classes I've ever taught. As I've said in other videos, I think in large part because there were faculty members in the room who were facing them, and that wasn't exactly a conducive setup to participation and cutting loose. So after the oath, you'll keep going. As usual, you want to outline some of the objectives for the class, for what you're going to learn. The real points that you want to hit here are like point number one, you want to talk about the 3 sneaky ways that SAT math questions will try to hoodwink students, and you're going to assure them that you're going to teach them go-to strategies to avoid being duped. And then I would also really highlight the fourth one here, which is you can tell students, part of what we're going to do today is we're going to go over those questions that you might look at and you might say, I just don't even know where to begin. You just sit there and you get stumped. And that's really one of my core goals for today is to make sure when you take this test, whether you're taking it next weekend, a month from now, later this year, that you know exactly what to do when you face a problem that tends to stump a lot of students. So that's really all you want to hit on this page. And then you can say, so, let's dive in here. And for the SAT math format, as it says here, there's a lot of text on this page. Like all this stuff here, students generally find kind of amusing here, but it's really meant to be read versus read aloud. It's meant to be read on their own. There's really this is a quick page where you only have a couple of points, really just two main points. Point number one, you have to make sure that all of your students know that there's two back-to-back math tests on the SAT. Remember, the overall sequence on the SAT is reading, followed by a writing and language test, followed by consecutive math tests, followed by that optional essay. So the third and fourth tests in that SAT sequence are both math tests. The first of those two math tests is actually the 20 question test, okay? The 20 question test is a non-calculator permitted test, which is really important that students know that. And then after that, students face a 38 question test, which is calculator permitted. This is a departure for the SAT. The old SAT allowed students to use their calculators on the entire thing. And then on the new version of the SAT, which again debuted in March of last year, March of 2016, they decided that they were going to give students a shorter math test that did not permit their calculator. So after that, you're going to segue here, and that's a really good building block, and it's about 9:10 in the morning at this point. And that's actually a really good springboard, because what a lot of students will be thinking is that, why don't they let me use my calculator? I've been using it my whole life. Why did this come about? And you can say to students, some of you might be thinking, it's a little bit frustrating. Why can't I use my calculator? I don't want to have to do all that computation. But I want you guys to know something. It can be a little bit of a blessing sometimes that a problem is a no calculator permitted question, and here's why. Sometimes the fact that a problem does not enable you or allow you to use your calculator actually serves as a clue for the fastest way to solve it. So here's what you're going to do. You're going to start off by writing this problem down on the whiteboard, and you may find that some students will be solving the problem as you go along. That's fine. You just want to say something to them like, and you'll see this in the clip that I show you guys from the class that I taught, like, hey guys, I see some of you are starting to solve this problem. That's okay. I just want to make sure you pay attention here, because again, I want you guys to understand that sometimes the fact that a problem doesn't allow you to use your calculator is, again, often a clue for the fastest way to solve it. So what you'll do is you'll write this on the whiteboard. By the way, if you don't have a whiteboard on day one, let us know so that we can make sure you have one on day two. It wouldn't be a big deal if you didn't have it on day one, because you're just doing the verbal portions. On day two, that would, needless to say, be significant. So you'll write this on the whiteboard, and you can say to them, so let me ask you a question here. What do both sides of this equation, what do they have in common here? What expression? You're right, they both share this expression in parentheses 2n minus 6. One of the things that the SAT math tests really like to see if you can pick up on are patterns, symmetries. And I can tell you guys strategy-wise that whenever I've got something like 2n minus 6 on both sides, what I want to do here is I'm just going to pretend that equals x. I'm just going to say 2n minus 6 equals x. And now I'm going to rewrite the problem, okay? I'm going to rewrite it as negative 3.5 x equals negative 4.5 x. Let me ask you a question. What is the only possible number that x could be that would make negative 3.5 times x equal to negative 4.5 times x? David, you're right. X could equal 0, right? Because if I say x equals 0, well, I would get negative 3.5 times 0 is 0. Same thing here. I would get 0 equals 0. And since x equals 0, and x equals 2n minus 6, and I've checkmated this problem, okay? Now, I want you to think to yourselves, if I didn't do it that way, how do you think most students would actually approach this problem? What do you think most students would do when they were faced with negative 3.5 times 2n minus 6 equals negative 4.5 times 2n minus 6? How do you think most students would go about solving that based on the way they've been taught at school algebraically? Ellen, you're right, yeah. They would distribute the negative 3.5 on the left and the negative 4.5 on the right. And since they don't have their calculator, they would be sitting there doing things like, okay, negative 3.5 times 2, I think that's negative 7. And then they would be negative 3.5 times negative 6, and it's 321.0. And so, and in any event, the point is, it would take them a while, right? Because they'd have to do basic computation without the aid of a calculator. And I want to tell you guys something that's really important here for that 20-question math test, the no calculator permitted one. The SAT does not test basic computation. If you find yourself doing something like negative 4.5 times 8 or 6 or something like that, that would normally require a calculator, it doesn't mean you're doing the problem the wrong way. You can get the right answer by distributing the negative 3.5 and the negative 4.5 and then isolating the n and solving. That will get you the same answer, n equals 3. But it's not the fastest way to do this problem because you're going to get bogged down in computation. So the fact that this problem is actually a no calculator permitted question serves as a clue that should let you know the fastest way to solve it, okay? So at this point, let's cut away and I'll show you a brief clip from the class that I led, again in Texas, where you can see a little bit of an overview of this. You'll see a few things here. First of all, you'll see that there was a student who actually was pretty funny. He came up with kind of a wise ass remark. I think I said to him, like, or to the class, what do you think most students would do if they were, faced with this question? And I remember he said, cry, which I thought actually was pretty funny. And then I kind of one-upped him a little bit and just improv riffed on his response and gave some alternate responses that students could have said. You'll also notice that I'm using the whiteboard. They actually only had a tiny little whiteboard because I was doing it in like the library area. And then 3, I realized at a certain point while I was actually explaining this problem, normally in this problem I would say something to the effect of, your teachers at school have taught you for so many years, you're very conditioned to program, to do things algebraically and distribution, and this is not like that. But I realized that there were teachers that were sitting in back of me. So I sort of caught myself. And I turned it into a little bit of a compliment. And I think I said something to the effect of, you've had some, teachers, they're really great teachers who've taught you, to do things this way, but there's an alternate way to do it. So in any event, let's go to that clip now, and then we'll come back and keep going. What do most high school students, what do you think you guys do if you're going to solve this problem? Like, what would be your first step?
This specific problem?
This specific problem.
Cry.
What's up?
Cry.
Okay, beyond crying is a really good answer. Crying, pulling out your hair, chewing on a number 2 pencil, possibly cursing the fates that you have to take the SAT, wondering why this in the Western Hemisphere SAT math is considered a rite of passage. All those are viable answers. However, in addition to those, if you mathematically were about to try to solve this problem, mathematically speaking, what do you think you would start doing? Go ahead.
Times.
Or go ahead, just because you had your hand.
Put the letter on both, like the same letter on one side.
Okay, so you would be moving toward isolating the end, right? Isolating the variable. What would be your first step, though? Go ahead.
Distribute.
Okay, that's the answer I want to hear. You would distribute, right? So you would write something like, negative 3.5 times, what is it, 2n minus 6, I think? Equals, what is it, negative 4.5 or 4.5?
Negative 4.5.
Negative 4.5 times the same quantity, right? So most students, because you've been trained by the way, really good teachers in algebra, and this is just elementary algebra, would start distributing the negative 3.5 times 2 and the negative 4.5 times 6 and all that. There's an issue with that. And I want you to think about this. It's not just about getting the right answer. Could you get the right answer that way? Of course. And we'll get to that in one second, you're right. It's about getting the right answer in the shortest amount of time. All right, so you just saw how that worked in a classroom of students. So again, this page really serves to talk about how to tackle non-calculator problems. And this page also serves as a springboard to talk about what are known as grid-in problems. Obviously here we don't have A, B, C, D. We don't have multiple choice answers, right? So you're going to use that as a springboard to get to page 255 here and say, so, you might have noticed, obviously, on that last problem that we did, that you didn't have any answer choices, that you had to fill in your own answer. So here's the deal. On the SAT's math test, on both the non-calculator permitted section and on the calculator permitted section, you're going to have a total of 13 questions that don't give you A, B, C, D answers, that have grids that look like this. The SAT calls these questions student-produced responses. Most people, ourselves included, call them just grid-ins, okay? So here's what I want you guys to know, all right? Let's look at another problem here. We have x squared is greater than x to the fourth. What is one possible value of x, right? Let me ask you a question here. And what I'm doing is, by the way, I'm essentially posing this. Would negative 1/2 work as an answer for x? If I said to you, is negative 1/2 squared greater than negative 1/2 to the fourth power? Yeah, it would. You're right. Because if negative 1/2, in parentheses, squared, is greater than, right? Because this would give you 1/4, positive 1/4, right? Any negative number to an even power is going to be positive, right? And this would give you 1/16, and 1/4 is larger than 1/16, right? However, why can't negative 1/2 be an answer to this SAT problem? Because there's no way to bubble in a negative answer. There's no negative symbol, right, on this grid-in. So that tells you if you get a negative solution to a grid-in problem, that means you've automatically done something wrong. There's no way that can be the right answer. In addition to that, notice here, we've got 1, 2, 3, 4 spaces in which you have to write your answer. So that tells you that if you get something like, 0.0001 as your answer, that could never be the correct answer because, again, there would be no way to bubble that in. The very largest 4-digit number that could be bubbled in would be 9999, and the very smallest digit, obviously 0 could be an answer, but if you want to use a decimal, the very smallest decimal would be 0.001. That would be the smallest, okay? So it's important just that students know there's no negative answers for grid-in problems. There's no way to bubble in more than 4 places. 2 more things for grid-ins very quickly, or actually 3 more. And they're written here. You would be remiss if you didn't tell your students that if they get an answer like 2/3, they could bubble that in as either 2/3 as the fraction, or they could bubble that in as 0.667 or 0.666. All 3 of those would be marked as correct. What they could not do is they couldn't round and truncate. If they were to bubble in 0.67 or 0.66, unfortunately the SAT would mark them wrong. So you want to make sure that you're always filling in all the spaces for a repeating decimal. And the safer way to do it is just to use the fraction form, right? So if I've got something like 1/9, which equals, 0.111 repeating, well, in that instance, actually it wouldn't matter because 0.111 keeps repeating, but I would want to make sure that I didn't truncate it. So if the answer were 1/9, I would want to write in 0.111 or 1/9. What I wouldn't want to do is I wouldn't want to write in 0.11. And then the other thing that I would talk about with your students, and this is something the SAT doesn't tell students, and it's really frustrating that they don't. It would be no skin off their back for the proctors to mention this, and they don't, and it's not in the directions, and I think it's really lame that they don't do this. So the math tests, rather, unlike the verbal portions of the SAT, they get progressively harder. The questions get more challenging as students go along. Okay, but there's an asterisk to that. Because the way that the math tests work, if you were to graph it, and you can show this to students on the whiteboard, if you were to graph it and you had like on the y-axis like difficulty level of the questions, and on the x-axis you had the question number, what you would find, for example, for the 20 question math test, is the graph would not go steadily from 1 to 20. It wouldn't go steadily up like that in terms of difficulty level. It wouldn't rise steadily. What you would see, in fact, is that for the multiple choice portion of the exam, so questions 1 to 16 are multiple choice, questions 1 to 16. And for those questions, it gets progressively more challenging up until question 16, okay? Or up until questions 15, rather. I'm going to make that a 5. And then from questions 16 through 20, it drops back down in difficulty level and gets progressively harder up until question 20. Why does that matter? That matters because all of the questions are worth the same number of points. And obviously students aren't going to skip anything because there's no penalty for guessing. But sometimes what will happen is students will get to like questions 14 or 15, the hardest two multiple choice questions on the no calculator permitted math test, the 20 question test, and they're going to get really stumped. And some students will say to themselves, why should I even bother going on to question 16 if I can't even get question number 14 or 15? And what those students fail to realize is that once you go past the multiple choice questions, once you go into the gridden questions from questions 16 to 20, the difficulty level resets and it drops down and gets easier again. So question number 16 is actually de facto question number 1. So if you have time and you're doing all right pacing-wise, I actually did that in far too lengthy a manner. You could probably chop off about a minute on that. But it's an important point to make because, again, the proctors don't mention this. The exam's directions don't mention it. I think it's really underhanded that they don't. And it's an easy way to make sure that students don't start getting inside their heads and realize that the difficulty level resets once you start hitting the gridding questions. All right, let's keep going. In terms of the math content, this is a really quick page. It's almost a little bit just to sort of poke fun at these kind of silly titles that the College Board came up with for the 4 broad categories of math questions. So you can just tell students you're going to face 4 overall categories of math questions. These are the category titles that the College Board came up with. You've got Heart of Algebra, you've got Problem Solving and Data Analysis, you've got Additional Topics in Math, and then you've got this really ludicrous title, Passport to Advanced Math. Don't really worry about those categories. What we're going to do today is very similar to what we did during the writing and language portion yesterday. I'm going to be giving you guys strategies and tips and shortcuts for cracking some of the most commonly tested types of questions that you're guaranteed to face on the SAT's math test, on both the no calculator permitted math test and on the calculator permitted math test. And as I said earlier today, we're going to also focus on some of those questions that really tend to stump students. So let's move on here. Before we actually dive in, I just want to make sure that you guys understand that, I know that some of you, mentioned yesterday when I asked you how many of you find the reading test to be the most challenging. Some of you also said that you find that the math to be incredibly challenging. And with math, what a lot of students do, again, is they'll look at a problem and they don't quite know where to begin. They don't know what to do. And we mentioned this yesterday during the writing and language portion and the reading test, but I want you guys to understand again that the math portions of this exam are just as predictable as the verbal portions, okay? Even though the SAT changes the types of questions from exam to exam, if you were to open up like the March SAT and you were to look at those math questions and you were to place those math questions side by side the math questions from, let's say, the October test, what you would find is, even though they're not repeating the exact questions, the types of questions are utterly identical. So my goal for the next hour and a half or so for you guys is to make sure that when you take this exam and you look at a math question, you think to yourself, aha, I remember doing that type of question during the boot camp. This is the strategy that we used to crack that type of question. Therefore, because this question is so similar to it, I can probably crack it using the exact same strategy, right? And really what we're talking about here is called pattern recognition, which is a term that's used in psychology, in computer science. It's actually it's all encompassing. It encompasses so many things in life, from karate and martial arts, as we see here. If you learn in a lot of defense classes that if somebody is coming at you in a certain fashion, that you can use a certain move to block them, as we see here with the 80s guy Jean-Claude Van Damme. It's used in chess. Here we see Russian chess master Garry Kasparov, who is facing off here. And then even in dating, people start realizing, well, this particular strategy didn't really work for me when I was asking someone out. So maybe I'm gonna change things and I'm gonna use a different strategy, and that worked for me. So I'm gonna use it over and over and over again. So all of us as humans are really hardwired to start detecting what works and what doesn't work. And again, what we're going to be focusing on are proven strategies that we know work for the problems on the SAT's math test. So just to really show you guys how this will work, I want to warm us up here. I want you guys to please flip with me to page 260 here. And what I'd like you guys to do is I'd like you guys to try this problem on your own. Take about a minute or so, and then we'll go over it as a class. So you'll give students a moment to do this problem. You'll give them probably about 30 to 40 seconds at most. And basically, this problem, like the problem that you did at the start of day one, is essentially a little bit of a trick question. But you don't want to reveal that as you're going along, as it says here in the teacher edition notes. You want to play this off as though it's just a typical warm-up question. And then you can say to students, by show of hands, how many of you guys got choice A? And you can raise your own hand as if it's the right answer. Okay, how many of you guys got B, C, choice D? And what you'll find is usually most students in the room will pick A, and a couple of them will pick choice D. D happens to be the correct answer. And you can say to your students, so let me ask you guys a question. For those of you who picked A, what you probably did is you said, okay, I want to make the biggest possible number, the largest possible number out of the numbers in these three sets. Well, the largest number in each set is 9, right? So, okay, cool. I'll do 9 plus 9 plus 9 equals 27. Sweet, this one's easy. My answer is A, right? But there's a problem with that. The SAT math test isn't just a math test. It's also a reading test. And one of the things I want to emphasize with you guys today is that it's very, very important to pay attention to key terms. Can anyone pinpoint for me, maybe one of you guys who got choice D as the answer, can any of you pinpoint what the key term is in this problem that enables me to get 24 as my answer rather than 27? Chris, you're right, yeah. The term different, right? If three different numbers are selected. Because if I don't see that word different, sure, I'm going to pick 9, 9, and 9. But if I see the word different, I know that I can't use the same number. So therefore, the only three numbers that are different from one another that are still the largest are 9 plus 8 plus 7, right? Which equals 24, which is the correct answer, D. This is our trap answer, choice A, okay? So I want you guys to bear that in mind, and now I want you to try this problem on page 261 rather. I'll give you guys about 20 seconds to try this one. So 20 seconds goes by, so okay. How many of you guys this time got choice A as your answer? Huh, none of you guys. How many of you guys got choice D? Huh, all of you guys. You all got choice D, and none of you got choice A here. Choice A would have been if you did 8 plus 8 plus 8. Technically speaking, is this problem identical to the one on page 260? No, but it's awfully similar, right? It's almost like a twin to the problem, right? So what happened between pages 260 and 261 is that you learned a particular type of trap, which is how the SAT will bury key terminology, and if you don't spot those terms, you unfortunately miss the question. You remember that from page 260. You instated that technique of paying attention to key terms on page 261, and you got the right answer. That's going to be what we're going to be focusing on for the rest of this math section, is really teaching you guys against strategies, not only to get the right answer, but to avoid those careless mistakes. Because I'll be honest with you guys, remember, this is a reading test as much as it is an SAT math test. And for those of you who who might take the test and maybe you got about 60 or 70 points lower than you were anticipating, here's the thing. Odds are that you actually might have just made careless errors. Or more precisely, the test induced you to make careless errors. So again, what we're going to focus on here today, or part of what we're going to focus on, are strategies to avoid the SAT's tendency to try to trick us into making careless mistakes. And if I want you guys to please flip with me now, we're going to dive into some specific types of questions to page 263. And you'll take a sip of water as I just did. And you can say the first type of question that we're going to tackle here together as a class is we're going to talk about strategies for solving problems that the SAT claims, you can italicize claims, reflect the real world of teenagers and adults. Personally, I don't think that there's anything that mirrors the real world in these problems, but we can't battle the College Board on that. all we can do is teach you guys techniques for solving these. So let's flip the page here. Let's check out what the College Board thinks is an example of a real world problem. And by the way, here in the teacher edition, and you can do this if you like. Usually students will find this kind of amusing. You can kind of poke fun at the notion that these problems are real world problems by just having the class recite along with you the ha 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 and ha that's on this page. Usually students will find that kind of amusing. I mean, there's just something in the act, almost like the oath, of having students recite things that are kind of goofy that tends to, really break up the monotony of the class and keep the energy level on high. So I would recommend doing that. So then you'll have students turn to this page. You can either read this one out loud, or you can have a student read it out loud. Let's say that you're reading it out loud. So Maurice and Edna each ordered a meal at a local restaurant. I love how they never ever name the restaurant and they pick these names like Maurice and Edna. But anyway, the price of Maurice's meal was D dollars and the price of Edna's meal was $5 more than the price of Maurice's meal. If Maurice and Edna split the cost of their meals evenly, each paid a 20% tip, and were actual non-imaginary human beings, which of the following expressions represents the total amount in dollars that each of them spent or paid? Okay, so what I'm going to do here is I'm going to teach you in a very, very effective strategy called plug and chug. Okay, some of you may already know the strategy. How many of you guys, by show of hands, have heard of the strategy plug and chug? Okay, a couple of you guys. Yeah, this is a very, very useful and versatile SAT prep strategy for the math portions. So here's the deal. Out of the 58 math questions that you're going to encounter on the SAT, you can probably use this strategy about 10 times. And the way that you'll know whether you can use this strategy, if you've got a math question, particularly word problems, that has variables, like the variable D here, in the problem itself, and in the answer choices, you can use a strategy where you can plug in nice, easy, real-world values for the variables and solve the problem that way, essentially shortcutting the algebra. So you don't have to do it that way. You can do this one algebraically, but let's do this together as a class to make sure that you understand this strategy. So I'm going to say, for example, and I'll be writing this on the whiteboard, I'm going to say that D equals 10 bucks, right? And you want to make sure that you pick nice, easy numbers, and you always, always write down the number that you select to represent each variable. In this case, there's only one. So now, basically, Maurice spent 10 bucks. So I'll write Maurice equals 10. And it says that Edna spent how much more than Maurice? Jackie, you're right. Okay, $5 more. Thank you. So Edna equals 5 bucks. And what does this problem ultimately want us to solve? Who can tell me? Chris, yeah, you're right. It wants us to solve how much they paid. And is it how much? I'm glad you're right. It is how much they paid. But is it how much they paid combined? Yeah, okay, good. It's how much each of them paid, right? So another strategy that I want you guys to start instating, and I promise you, even though this is a little bit annoying, it will save you from making careless errors, is I want you guys to get in the habit of underlining the final question that you're being asked, okay? So here, we want to know the total amount that each of them paid, each, okay? That way, I'm not going to fall into the trap, and you can bet that trap is there, of picking an answer that combines how much they paid, both of them paid, right? So they paid, how much did each of them pay? Well, Maurice paid 10 bucks, Edna was $5 more, so Edna paid $15. So combined, they paid $25, right? Let me rewrite that to be a much more legible 5. I have the handwriting of like a gastroenterologist. So that's $25. And now it says, who can help me out here? It says they each paid a 20% tip, right? So how can I figure out how much they would pay including the tip? Brian, yeah, you're right. I could do $25 times 0.20, because that's 20% as a decimal, right? That would get me $5. I can then add that $5 to the 25. That means they paid a combined $30, right? That's one way to do it. And you're right, you can do it that way. There's actually a slightly faster way that I want to make sure you guys know when you're dealing with decimals, okay? Another way that you could do this, instead of taking 25, multiplying it by 0.20, and then adding that amount, which is 5, back to the 25, which is perfectly fine, you can just shave off a couple of seconds by doing 25 times 1.20, and that will equal $30, which is the combined amount. It's not that it's that much faster, But remember, if you can shave a little bit of time off of every single question, in the aggregate, those seconds will start adding up, and you might save yourself like 2 minutes total, which can actually mean the difference between one or two questions on the SAT. So again, I can multiply that by 1.20 because that would be a 20% increase, right? And that's $30. Am I done? Nope, I'm not done, because remember, I want to know how much each of them spent. So it says they split the cost of the meal evenly, right? That's somewhere here, split the cost of the meals evenly. And so that would mean I take 30 divided by 2 and I get $15. So that's my answer. Now, some of you might be thinking, well, I don't see 15 among your answer choices. I see a variable and some numerals, right? So here's the deal. The reason that we wrote down the original value we selected for D is that now the final step in this process is you're going to take that value, you're going to plug that value into A, B, C, D, and you're going to see which one of those answers equals 15 when you substitute 10 for D. And lo and behold, the correct answer here is B, because 1.2 times by 10 plus 3 equals 12 plus 3 equals 15. Okay? Now, here's the deal with this problem. And this, I'm speaking to you guys as gurus, not as students. So this is going to be a godsend to some students, particularly students who might be a little bit math phobic or who struggle in math. And it's also going to be something that where you're going to have the students who are really gifted at math. Sometimes they get a little almost like touchy or defensive. They want to do it algebraically. So again, be prepared for questions or statements like, wouldn't that take longer? The answer is, listen, if you feel that you can do this one faster algebraically, go for it. Do that. Again, I just want to make sure that for those of you who might be daunted by approaching this problem algebraically, that you have a different and equally viable way to solve this question. So just be prepared for that, okay? And then you also might get the question, what if we didn't select D equals 10? What if we selected some other number? That's the beauty of plug and chug, of this strategy. It can work for any number you pick. The only numbers you really don't want to use, you don't want to use 0 and 1 because they can mess up your problem. You want to make nice, easy numbers. I mean, look, if I wanted to, I could have said, instead of Maurice spent $10, D dollars, I could have said D equals like $712.84. I still would have gotten the right answer, but I would have made my life fairly miserable, okay? Even though this is actually a calculator permitted question. And I, by the way, should have said that. So this is calculator permitted. So anyway, let's move on here. And now I want you guys to put that into practice. And you'll notice here that on the following pages, on 266 through 268, what we've done is we've given you guys a step-by-step process. We're not going to go over that, but again, throughout today, I want you guys to know that after this weekend, you can always refer back to this. This is a giant cheat sheet for you, this book, and you can go back and read our step-by-step process for cracking these questions. Okay, so let's go to page 269 here, guys. And I'm going to give you guys about a minute or two. So we just did a problem that's a plug and chug problem that would be like an easy or a medium type of question. Now let's try one that's very closely modeled on one of the hardest questions on an actual SAT. This is a much more challenging word problem, but we can still crack it using that same strategy of substituting nice, real-world, easy numbers for the variables. So I'll give you guys about a minute, try this on your own, and see if you can get the answer. So here's the deal with this question. So I mentioned as we in my explanation of the other problem, I'm again speaking to you guys as gurus now, not as students. You might have one or two students, those who tend to be mathematically inclined, who kind of give you a little bit of pushback on plug and chug. We're like, I like to do this one algebraically, etc. What you're going to find is going to happen here is those students can be pretty cocky at math. And it's not that they're not, they're probably great at math, but they tend to make careless errors. They just look at a problem, they think they can solve it, and sometimes they're wrong. So some of those students will actually pick trap answer A here. What those students will do is they'll read over this question, and they'll say, okay, sofa is D dollars, each additional sofa is at a discount of Y dollars, so this second sofa is D minus Y dollars. We're buying S sofas total, so okay, D plus S times D minus Y, that's my answer. They'll bubble an A, and they'll move on, thinking they got the right answer, not realizing they were lulled into picking an obvious trap answer, a distracting answer. So it's okay. You actually kind of want a student to say choice A here. When you say, does anyone have what they think is the right answer here? It's you almost want to call on a student who looks like that student might be more mathematically inclined and have that student say A so that you can say, and I'm going to go back into teaching mode here, you could say, believe it or not, A is actually the number one trap answer that most students, particularly students like yourself, and I can tell you're really, really good at math here, I have no doubt about it, Let me ask you a question. So, Chris, I know that you said that you picked A here, and that's okay. Again, I'd rather you make that mistake in here than to make it on the actual test. And how many of you guys also picked A here? Please be honest. Raise your hand. Okay, a lot of you guys. All right. So clearly, choice A is tempting. So probably what went on in your heads is that you figured the sofa is $D, and the next batch of sofas are going to be S is the number of sofas. There's a Y dollar discount, so S times D minus Y, right? You didn't even do any work. You just bubbled in the answer. Is that correct? Good. All right. I'm glad that you guys are being honest here. But there's a catch to this. Remember, the SAT math test isn't just a math test. It's a reading test. So let's try to work this one out on the board here. Let's try to work this one out on the board. So I'm going to do this one for us. So I'm going to use the strategy of plug and chug. Why can I do the strategy of plug and chug here? Well, I know that I can use that strategy because, again, I've got variables in the question itself, and I have variables in the answer choices. So I'm going to make up some values here. I'm going to say D equals $100. That's the cost of a sofa. I'm going to say that Y equals $10. That's going to be my discount for additional sofas here. And I'm going to say that we're buying S equals 3. We're buying 3 sofas. And who can help me out? Remember, what strategy do I want to do to minimize careless errors? Sophia, you're right. Yeah, I want to always underline the final question that I'm being asked, just to make sure before I bubble in my answer that I'm answering that final question. Here, we want to know the customer's total cost for all the sofas bought during the sale. All right, so let's figure out how much dough this customer spent. So I'm going to do this on the whiteboard here. So we've got 100 for the first sofa, and we've got 90 for the next sofa, and we've got 80 for the next sofa, and 100 plus 90 plus 80 equals 270, right? Oh, okay, I made a mistake. You guys are right. You guys, I can't get anything past you. What did I do wrong there? Who can tell me what did I do wrong there? Why is it not 100 plus 90 plus 80? Cindy, you're right. Yeah, it's not Y dollars less than the previous sofa. What does this problem say? There's a very important 5-letter word here. Yeah, you're right, Cindy. It's the word first. This word problem here, which is challenging, says each additional sofa the customer buys costs Y dollars less than the very first sofa, right? So it's not going to be 100 for the first sofa, and then 90 for the second sofa, and then 80 for the third. It's just going to be it's going to be 100 for the first sofa, 90 for the second sofa, 90 for the third sofa. No matter how many sofas I buy, each one's still going to be $90 after that first one because of that key 5-letter term. So now 100 plus 90 equals 280. And I can go A, B, C, D, and I can figure out which answer choice equals 280. And who can tell me what the correct answer here is? Amy, you're right. The correct answer here is choice D, right? And the reason we have S minus 1 is we have to take into account that very first sofa. So now you've seen just how versatile plug and chug is. And again, I can promise you guys, you're going to have problems like this when you take the SAT, and you can probably use this strategy about 10 times on the 58 questions on the math test. And really, so what we're doing here is I'm working these discussion questions organically into my discussion here on page 269. And then I want to build on that, and I want to talk about the critical importance of key terms here for students. And I can say to students, so flip with me to page 271. We just saw how if you don't notice that term first, you don't get the problem right. There's certain words that the SAT uses over and over and over again, tries to really like bury them, particularly in word problems. So I want you to look at the bottom of the page. I'll just read these out loud. And these are the words that I would really pay attention to. I would star these words in your book so that you can study them later and make sure that you always look out for them. Least, greatest, other, different, only, positive, negative, even, odd, consecutive, integer, number, positive, negative, non-negative, all, total, everyone, some, and each. By the way, some of you may notice I'm talking to you guys who are gurus, not students, that we accidentally repeated positive, negative. Obviously, that's a typo. No need to point that out unless students notice it. If they notice it, you can simply say that's, yeah, a typo. We thought it was so important that we actually repeated it twice or something to that effect, okay? From there, you're going to go on. This is a bridge page, and you're going to go on to some of the other types of math questions students will face. And you can say to students, so we're going to go on here. We're going to look at some of these, again, the more common types of math problems that you're guaranteed to encounter. And we're going to try to do this in as entertaining or at least non-boring manner as humanly possible. So you'll see here this picture of Matt Damon here on page 279 or 273. And let's dive in here. We're gonna start off here by talking about SOHCAHTOA and foundational trigonometry. Okay, how many of you guys at school, by a show of hands, have studied SOHCAHTOA? Okay, actually, a lot of you. Well, that's really good news. Out of the 58 math questions, you'll usually face one or two foundational trig problems, and there's usually two forms of them. The most common form, or the more common form, is actually to give you problems based on SOHCAHTOA and triangles. And just to refresh that, because I know some of you haven't studied that at school, that's okay. If you haven't gotten to SOHCAHTOA, I know some of you are also freshmen and sophomores in this room. If you haven't, what we're about to do will give you a little bit of a leg up when you tackle this eventually at school. So here's the deal. We're going to use infamous celebrity love triangles to refresh the foundational trig concept of SOHCAHTOA. Okay, so let's flip the page here, and we see that we have this love triangle formed by John Mayer, Katy Perry, and Taylor Swift, and this was something that was in the Paris Hilton a lot a couple of years ago, etc. One of the more infamous celebrity love triangles. Okay. By the way, again, you obviously you don't want to in any way sexualize this for your students. This is already about as kind of pushing the envelope as possible. I think this is pretty PG and pretty benign, but you don't want to take a chance in any way further sexualize this for your students. I can't emphasize enough that you're dealing with minors, which is no cursing, no sex, no drugs, no rock and roll, none of those references. Just play it really, really careful. So, in any event, let's refresh what we mean by SOHCAHTOA. Okay. So when we're dealing with a triangle here, before we get to these problems here, for those of you who maybe have done SOHCAHTOA at school, who can tell me what does the S stand for in SOHCAHTOA? Jamie, you're right. Yeah, it stands for sine, right? Which can be spelled this way or this way, right? Let's have a triangle here. Okay, we've got our triangle like this John Mayer, Katy Perry, Taylor Swift one. I'm drawing it on the whiteboard here. Let's just say this is a 3, 4, 5 triangle. Even though my drawing is not very good, let's say it's a 3, 4, 5 triangle. Okay, and so that would mean that this here. If I said to you, what is the sine? What is the sine of x degrees, right? So what does the OH stand for here? OH stands for, you're right, yeah, Jamie, opposite over hypotenuse, right? So this, if I say the sine of an angle, all I have to do, and again, I know some of you know this, is I have to go to the opposite side, which in this case would be 3, take that 3 value, because that's opposite side, and put it over the hypotenuse, which is 5. So therefore, the sine of x degrees would be either 3/5 or 0.6, which is 3/5 as a decimal, right? And if I wanted to know, let's refresh this a little bit further. If I wanted to know the cosine, C stands for cosine. If I want to know the cosine, what does AH stand for? Who else knows this? Macy, you're right, yeah. AH stands for adjacent over hypotenuse. So the cosine of angle x would be the adjacent side, which is 4, over the hypotenuse, so 4/5 or 0.8, which is just 4/5 as a decimal. And finally, if I want to know t, which stands for tangent of the same angle, angle x here, tangent stands for opposite over adjacent, right? Opposite over adjacent. So the tangent would be opposite side over the adjacent side, which is 3/4 or 0.75, okay? So it's a little bit of a refresher. And again, if you haven't studied that at school, that just gives you a leg up there on something you will probably tackle perhaps this year. So now let's utilize that information and let's try a problem that you probably wouldn't face on the SAT. I mean, you never know, but probably not. But exactly the same type of question you would face on the SAT. All we've really done here is instead of giving you numeric values for these side lengths, we've just put John Mayer, Taylor Swift, and Katy Perry. So who can tell me, based on right triangle, Taylor Perry pictured above, what is the value of sine of x? Well, yeah, you're right. Sine of x would be opposite over hypotenuse. So that would be choice C. That would be choice C. You'll notice here what you're doing with students. By the way, I'm talking to you guys as gurus now. What you're doing with students is I'm not saying Perry over Mayer because that can have a sexual, kind of, vibe to it, right? Or overtone. So rather than saying Perry over Mayer, I'm just going to say which answer choice is right, A, B, C, or D. Let the students just say C. Same thing for number 2, which is going to be choice A. Okay. From there, you're going to transition to exponential growth problems. This is among my favorite portions of the math to teach. I was an English major in college, and I like the way that the rhythm of this, the way that we get into it. Even though I'm not really a math person, I find that this one actually is something that students can use in everyday life after the SAT, because exponential growth and data can be important. So here's how I would get into this. So you can say to them, so here's the deal. We're next going to turn to one of the most challenging concepts tested on the SAT, which is the concept of exponential growth and decay. If you guys will flip with me to page 276 here, okay? And you'll see here we've got these pictures here. Anyone recognize maybe the picture on the right? Yeah, that's from the movie Gremlins, right? That's a picture of Gizmo, right? And if you haven't seen that, that's a great comedy from I think from 1984, and you can check that one out on Netflix or Hulu. But why do we have that sitting here in our SAT prep book? In addition to the fact that Gizmo is very adorable, we have that sitting here because in the movie Gremlins, spoiler here, if you haven't seen it, what happens is you have a suburban family that adopts this adorable little furry creature named Gizmo, but with a couple of ground rules, such as don't feed the creature after midnight, and the creature can't get water on it, right? And lo and behold, of course, what happens in the movie is that Gizmo eats after midnight and gets water on him, and what happens is he starts replicating, okay? He just starts spawning all these other creatures called gremlins. First you have one more of them, and then you have double, and it just keeps doubling and doubling and doubling. And in fact, that movie is an example of exponential growth. Exponential growth is when something just keeps doubling in size. It goes up very, very steeply. It's not linear. The graph would look curvilinear. It'd be a curve, right? And another more modern example of that, if you guys will flip with me to 277, how many of you guys have seen like the TV show The Walking Dead, or maybe a movie like World War Z? Yeah, zombies have gotten really popular these days. And, all zombie films, even though they differ from one another, kind of have the same springboard, which is essentially someone will get infected, like this little girl here, seemingly innocent little girl, somehow get infected. And then what happens is that zombie then infects others, maybe bites them or eats their brains or something else that's really grisly. And then all of a sudden you have one zombie, and then you have 2 zombies, and 4 zombies, and 8, 16, and so forth, until you have this horde of zombies that's attacking humanity. So all zombie pictures are actually also an example of exponential growth, okay? And so what we have here, if you'll flip with me to page 278, you'll see that what we've done is we've represented how the zombie apocalypse could look if you were to represent it in chart form, right? Day 1, 1 zombie. Day 2, 2, and then 4, 8, 16, as I said, and so forth, okay? So what the SATs, why are we doing this? We're doing this because one thing that the SAT will do when it comes to exponential growth is they'll test if you can recognize how exponential growth in chart form would be translated into graphical form, into a graph. So I want you guys to look at the chart that's on page 278, and I want you guys to be careful, and I want you guys to see if you can figure out which of the graphs on page 279 here would represent the data that's in the chart on page 278, okay? And before we do this, though, as a class, there's at least one, if not 2, of these choices that we can eliminate really, really fast, okay, really fast. Who can tell me, what can we eliminate? Stacy, you're right, yeah, we can eliminate choice A. Why is that? Yeah, because it's linear, right? Because choice A is a straight line, and we know that if we're going up very steeply in exponential growth, as I said before, it's not going to be linear, it's going to be curvilinear, right? And what's another choice that we can get rid of right away? David, yeah, we can get rid of choice B, right? Because it's going down. And we know that this zombie apocalypse is going to just keep going up and up and up, right? Okay, so we've gotten rid of choices A and B. Why don't you guys take about 30 seconds, see if you can figure out whether this one is C or D. And I want you to be careful. I want you to think very carefully about what's written here on the x-axis. So you'll give students about 30 seconds, if that, to try to figure out whether it's C or D. Couple points here. First of all, the correct answer here is D. A lot of students will think C, and here's why. The students will say, okay, well, it goes like 0, comma 1, and they're basically trying to like plot the points. But the thing is, this x-axis here has a key term, and the key term is the word since. Okay, this is tricky. And the way that I would explain this to students is I would go back to this chart here, and I would say to them, so this is representing days of the zombie apocalypse, right? But if I said to you, if I change this and I said to you, number of days since the zombie apocalypse started, it would change things. Because if I said to you, for example, on day 3 of the zombie apocalypse, there's 4 zombies, how many days since the start of the zombie apocalypse is day 3? Excellent. Really, really good, Cindy. It's 2 days since the start, right? Day 4 would be 3 days since the start. Day 5 would be 4 days. So actually, day 1 would actually be 0, okay? Because the very first day of the zombie apocalypse is 0 days since it started. And I know that I can see that some of you might be confused by that, but again, think about the implications of the word since. So now let's go back to our choices here, and the only one that starts at 0, 1 is choice D. So that's pretty tricky, and again, I want you guys to never lose sight of the fact that the SAT's math test is also a reading test. Now, you may have some students, I'm speaking to you guys as gurus now, you may have some students who kind of point out, rightly I might add, that there's a little bit of an issue with the graph here. Like if they really try plotting points and they're going like 0, comma 1, 1, comma 2, 2, comma 4, 3, comma 8. It's not an exact matchup. We tried to do that. It's as close as we can get. So here it's like 0, comma 1. That's pretty good. The next one should be 1, comma 2, and then we have 2 here, comma 4, 3, comma 8. Should then be 4, comma 16. So we got pretty close to it. If you have students who like are literally like busting out some sort of magnifying glass, but we got pretty close to these points in this graph. Okay, this graph does not match up with it. Okay, because it's skewed. That's not the correct answer. But choice D does more or less match up with it. And again, all of this hedges on the word since. So let's do a brief cutaway here. I want to show you guys how this played in the SAT in the boot camp that I taught. So let's cut away to that, and then we'll keep going. So in a typical zombie movie or a zombie TV show, what happens is you have one person who somehow gets infected, somebody, right? And that person then starts, or and whatever, zombies are like lurching around, and that person then infects rather another person, and then we have 2 zombies, and then they each go out and start infecting people. So you essentially get exponential growth of zombies. You have initially like 1 zombie, and then you have 2 zombies, and then 4, and 8, and 16, and so on, right? It's just doubling every single time. And in fact, if you look at page 239, what we've given you here is we've given you in mathematical chart form, we've given you days of the zombie apocalypse, which hopefully won't happen anytime soon. And we've got on the left side of the chart, we've got number of days, and on the right side of the chart, we've got number of zombies. Make sense to you guys so far? So let's flip the page, and let's start getting into how this pertains to SAT math. So one of the ways the SAT will ask you about exponential growth is it'll want to know if you can pictorially represent, if you can figure out which graph correctly represents exponential growth. So let's do this together as a class. So on page 240 here it says, who gets up? So on the x-axis of each of these, it says time in number of days since the Earth became a post-apocalyptic nightmare, right? On the x-axis. And then the y-axis says number of flesh-eating zombies. So which one of these, actually I'll have you guys do this on your own. Which one of these graphs represents the chart that's on the previous page, the exponential growth? Are there any choices that I can eliminate right away? At least one choice that I can eliminate. Which one? A, Y, you're right. Why can I get rid of A? What kind, is that, what's that? It's a straight line, so it's linear, right? It's a linear function. Good. So let's get rid of A. By the way, why can I probably get rid of choice B? Yeah, we'll keep going up, right? So A and B are automatically gone. Okay, so now that you saw that, let's keep going along here. And now what you're going to do is you're going to build on that, and you're going to show them another type of exponential growth problem. This one is not in graphical form. This is a word problem, but it's still testing exponential growth. So what I would do here is I would do this one together as a class, as it says here in the teacher edition. This is a no calculator permitted question. And you can really emphasize here again that the reason this is a no calculator question is it's not testing computation, it's testing a concept, okay? So this reads, of the following 4 types of retirement savings accounts, which plan would yield exponential growth of the money in the savings account, okay? So what you'll do is you're almost going to treat this like a reading problem here, okay? And you're going to talk about not just which answer choice is correct, but you're also going to talk about why the other answer choices are incorrect. And before you get to this, or as you're doing this, you want to make sure that students understand some important financial terminology here, okay? You want to make sure that students understand what it means for, things to like appreciate versus depreciate, and simple versus, compound interest. And I'll show you a clip of that in a minute, but diving in here, if you go to choice A, for example, it says each successive year, 2.5% of the initial savings deposit is added to the value of the account. Choice B, each successive year, 2.5% of the initial savings deposit and $500 is added to the value of the account. So, and then you'll notice that choice C is the only one here, only one that talks about the current value. And what you want to get students to understand is that choices A, B, and D are incorrect because they would represent linear growth, right? If I were to plot this, if I were to make this real, one technique you can use if you're ever like in doubt, right? If you're ever like, well, I don't really know here, you can say to yourself, well, let me actually put in some numbers here, right? What if I start with like $100, right? If I started with $100, for example, with choice A, and I said each successive year, 2.5% of the initial $100 is added, well, the first time it would be $100, right? That's my start. And then 1 year later, so that's basically at 0. 1 year later, I would get 2.5% of that, which would be $2.50. So then I would get $102.50. And year 2, I'd get another $2.50, $105. And year 3, $107.50. And if I plotted that out, same thing for choices B and D, I would have a linear relationship. If I plotted out choice C, the key here is it's based on the current value. This is really testing compound interest here. So here, for choice C is the correct answer, because if I plotted that one out, for example, initially I'd have $100, and that would be at the start, I'd have $100. And then after year 1, I'd have the same amount, it'd be $102.50. And here's where it would start diverging if I were to base it on the current, because after that, then I would be doing not on the initial amount, it would then be $102.50 times 0.025. I would be adding 2.5% and add that back, and it would be $105 and some change, whatever that would make out to be, but it would be over $105. So if I were to graph it, what you would find is it would go up more like that. It wouldn't be linear, it would be exponential. So the key here is, if you're sitting here thinking, you know what, I don't know if I could remember that for the day of the test, here's what you could remember. There's a very big difference between initial and current, or first and previous. If you have a problem and it wants to know about exponential growth, and it almost always wants to know about the exponential growth, not the linear, you can automatically eliminate any answer choice that talks about the initial amount, that it's based on the initial. So you can get rid of like A and B here. And you always want to go for the answer that talks about the current or the previous year, okay? So if you want exponential growth, you can get rid of initial and really zero in on the answer that bases the interest on what's currently in the account. So I want to take this even a step further, and we're going to flip here, if you guys will flip with me to pages 280 or to page 284 here, and we're going to talk a little bit here about also about compound interest. And before we do so, I want to talk to you guys about appreciation and depreciation. If you guys, any of you guys by show of hands, have someone who's in your family who's maybe like an accountant or financial advisor or someone who works in finance, yeah, so I can guarantee you that if you got someone in your family who's an accountant or a mathematician or someone who works in finance, they're probably really familiar with this formula top page 284 here, okay? Which is, again, just another form of exponential growth. So before I dive into this, I'm talking to you guys as gurus. I want to just cut away into another clip from the class that I taught, and you can see how I spoke a little bit about appreciation versus depreciation and simple versus compound interest. So let's go to that clip. So appreciate means that something goes up in value, usually money, and depreciate means it goes down in value, which most cars do. Let's talk about the classic cars, something like that, right? So if a problem tells me, you'll undoubtedly have this on August 26th. If I'm dealing with a problem that says that a value depreciates, that means it's decreasing in monetary value, okay? Also, if I say to you that something is, let's say that I have something that's, let's take an easy example this first. Let's say I have something that's appreciating at $100. So I have a checking account, there's $100 in there. And let's just say, for argument's sake, that I get 10% interest on my savings, that was more of a joke for those of us who have savings accounts. So, in any event, it'll be funny in like 7 years for you guys. So in 10%, right? So if I save my money and once per year it goes up, it appreciates 10%, how much money do I have at the end of that first year? 110, thank you. And if I say each year, based on what's already in there, it goes up 10%, then next year I would take 10% of 110, and that would be $11, and 121, excellent, and so forth and so on. All right, so now that we're back and you've gotten a little bit of an idea of how I structure that, so what you're going to do here is you're going to be introducing that concept, and you're going to be, before the students even dive into these questions here, you're going to be really walking them through page 285 here, which is why it says before tackling this. And you can use the whiteboard here, and you really, again, want to try to get students to understand that simple interest is linear, and compound interest is exponential, right? And so, which is why, if you have an investment, you obviously want to have exponential interest, not linear interest on that investment. Whereas if you owe someone money, you would much prefer to have linear interest versus exponential, okay? So, and you can also talk to them about what it means about, compounding. So for example, the problem here says, and you'll go back and it says, Matilda opened a savings account that earns 2% interest compounded semi-annually. Let's talk about what that means. So first of all, if I say something is semi-annual, what does that mean? How many times per year? Jake, you're right, that means twice per year, right? Same thing as biannual. Biannual and semi-annual both mean twice per year. I know that some of you might think biannual means every other year. That's biennial with an ENN, not biannual, okay? And also, what does it mean compounded? That's really just a fancy way of saying that it bears interest. So if I say something like I have an interest-bearing account and it earns 2% interest compounded semi-annually, all that means in basic English is I'm going to earn interest twice per year, okay? And remember, I don't want you guys to be daunted by these formulas. We're going to talk about that more in a few minutes when we get into science-related math questions. But you don't have to know this formula. They're giving it to you, okay? So let's try to do these problems here. We can do these problems here together as a class. What do you think would be the answer for the first one? Stephanie. 2. You know what? You're right. You're very, very close. You're right that R equals 2%. So you're absolutely right. But I want to be careful here. So, oh yeah, you're right. Yeah, so it's 2% expressed as a decimal, right? So it's you've got to express it as a decimal because that's what it says in the problem. R is the interest rate expressed as a decimal. So the correct answer wouldn't be 2. It would be 0.02, right? 0.02. And I could bubble that in. I could justify that left as it is here, or I could do, I could do that on the right. I could leave the first one blank and do 0.02. It doesn't really matter how I bubble that in, right? So 0.02 is the answer for the first one. You'll notice, by the way, I want you guys to know this. These two questions that we're doing here are based on the hardest two questions from an actual SAT, but they're really not that complicated if you don't get daunted. These problems are almost like all bark and no bite. The reason these were the hardest two on an actual test is that some students will get really intimidated by this formula, A equals P, etc. And also some students just won't know what we mean by like compound interest versus simple interest, semi-annual, etc. But all they involve is basic algebra. Let's try question number 2 here. Can someone walk me, anyone have what they think might be the right answer for this one? Stacy, 2.08, yeah, you're right, exactly. And how did you get that? Okay, you figured out how much money each of them has, right? Exactly. So for this problem, we want to know, and remember, it's always a good idea to figure out what do we want to solve here, because it's almost like a GPS. When you're solving a math question that involves multiple steps, you can think of the ultimate solution as like the destination where you wind up, where you want to wind up if you've got a really long road trip. And sometimes thinking about it in that way will actually help you to solve it. You can reverse engineer. You can say to yourself, what do I need to do to arrive at that ultimate destination? So here, what do we want ultimately? We want, excuse me, we ultimately want to figure out after 2 years how much more money Jeremiah earned off of his initial deposit of $100 than Matilda did off of her initial deposit of 100. And who can tell me what's the only difference between Jeremiah and Matilda in terms of their interest? Yeah, he gets 3% interest and she only has 2% interest on her $100. So what do I have to figure out? I have to figure out how much each of them made, right? So all I'm doing is I'm just plugging in numbers into that formula, and I can do this on the whiteboard. And Matilda earned this much, $104.06, and I'm rounding to the nearest penny here. Jeremiah, $106.14. Therefore, yep, 106 minus 104.06 equals $2.08, which is our answer. And you'll notice here it says round your answer to the nearest cent. So that's why we're rounding to the nearest penny. So again, what makes this problem hard? What makes this problem challenging is not even the formula, but that it involves multiple steps, and you have to understand what these terms mean. But this is just yet another example of an exponential growth question. All right, so let's move on here. And again, I know that some of you might have found this, might need to refresh this. So if you have any questions, you can always go back and look at these pages, on your own, and it talks about them step by step. All right. So you guys as gurus are obviously skipping that, and you're going to page 291, and you have an easy bridge to go from that last concept to this one, which is you can say to students, on that last question, we dealt with a formula relating to compound interest on an investment or the amount of money in a bank. For this one here, I mentioned at the start of yesterday that the way that the SAT gets away with not having a science test like the ACT is to actually take some science content and incorporate it into all the test sections on the SAT. The writing and language test, the reading test, both of the math tests. So the next couple of questions we're going to do pertain to science formulas. And there's really just two types of science-related questions that you're going to encounter. The first type will test you on your ability to just honestly plug numbers into a given formula that you, again, don't have to know in advance, and just solve for some sort of unknown quantity, which is essentially basic algebra. And the second type is the SAT seems to love these questions that ask you if you can rearrange the variables in a given formula to isolate one of the variables, just to rearrange it. So just to give you an example of that second type, let's flip the page here to go. Let's all go to page 292. We're on page 292. Any of you guys recognize this formula here? Take a second and see if you can figure this out. So really what we're doing here with students is we're seeing if they can recognize that C equals the square root of M is just E equals MC squared rearranged. How can we get that? Well, we can square both sides, right? So now this becomes C squared equals E over M. We can multiply both sides by M. And we get E equals MC squared. So yeah, you're right. And so what students will do, some students in the class will recognize this. You want to compliment them and say, yeah, absolutely, you're right, I'm impressed. This is just a rearranged version of E equals MC squared. How did you get that? And let them walk you through that. And you can use that again as a bridge to get to the next page. And you can say, so all we really did here is we proved that C equals the square root of E over M is just an equivalent form of E equals MC squared. And again, that's a very common type of science-related question that you'll face on the SAT's math test. So let's go to page 294 here. So you basically can just skip over 293 and kind of paraphrase this. Let's go to page 294, and we're going to do a couple of questions here that represent the two types of science-related math questions you're guaranteed to face when you take the SAT. And how many of you guys, I know I said this before, how many of you guys have seen the movie The Martian with Matt Damon? Good, okay, a bunch of you guys. So we're going to use this scenario and talk about And we're going to tackle two problems that, again, very much are representative of the types of math questions you can encounter. The SAT probably won't use Matt Damon-y questions. That's okay. They might, but you know what? They're still going to give you questions that pertain to physics, chemistry, biology, etc. And just to be really clear here, you don't have to know any of these formulas in advance. The SAT will always give you the formula. So you don't have to have any, there's no prerequisite knowledge of physics required here, okay? So let's tackle these. We're going to do these together as a class. Let's try the first one here. So what you're going to be doing with students is you're actually going to be doing, you're going to be making an intentional error here, okay? You're going to be intentionally making a mistake with this first problem here. You're going to use the whiteboard, and in a moment I'll show you how I did this in the actual class, and most students will be onto you. Most students will realize what the mistake is. And what you're going to do is you're going to use this formula here to figure out what we want to know here, which is how fast, so we're solving for the v, the velocity, how fast what must Matt Damon be traveling to reach 10,000 meters. So what you'll do with your students is you'll use the whiteboard and you'll say, okay, let's do this one together. So, okay, and you're basically doing this. You're doing, okay, h equals vt minus 1/2 gt squared, right? And then you're just plugging in for the values. We know that h equals 10,000. V is what we're solving for. Okay, time is it says, well, 2 minutes, right? It says that in the problem, 2 minutes. So I'm going to put in 2 for t, minus 1/2. G, it tells us, is 3.71 times t is 2 squared, right? And you're basically going to walk them through this. And you're going to say, okay, so the answer is 5,004, right? And at this point, students will start saying no, and they're going to be catching you on your intentional mistake. Because what you're doing is you're modeling for students a typical error that students make, which is you are modeling that you didn't take those minutes and convert them into seconds, okay? Because you'll notice here, what we want to solve for is v, right? That's what we ultimately want to solve for. It says how fast must Matt Damon be traveling, or his escape pod. But you'll notice here, it says t is the time that's elapsed in seconds. So here, when I'm plugging into my formula for t, it tells me 2 minutes. But in order for me to get the correct answer, I can't say t equals 2 minutes because it says t is the time in seconds. So I have to take those 2 minutes and convert them to 120 seconds, right? 60 seconds per minute. So that would then get me the correct answer, right? If I plug in 120 for t, I would get choice B. If I plug in 2 for t, I get trap answer C. And it's no surprise that they have that lurking there. Because again, what they've really done is they thought of every possible way that you can mess up a problem, all right? So that's a really good problem to do for your students. And let's actually cut away here and see how that worked in my class. So this is correct, right?
Do you have to change minutes a second?
Aha. Okay. You guys are right. So I made a mistake here. What mistake did I make?
You have to change minutes into seconds.
Excellent. Yeah. Very, very good. Okay, so now that we're back, let's do problem number 2. So for problem number 2, and again, the answers and explanation are on page 295 for you guys, for you, those of you who are teaching here. And really all you're doing here is you're illustrating with students. I would actually, for number 2, you might want to have students do it on their own and see if they can come up with it. But you're illustrating how you can manipulate that formula to take it and solve for G. So all you're doing is you're rearranging the formula just as you did in the E equals MC squared problem to isolate the G. And again, the steps are written out here. So that's something that you might want to have students do on their own and then review it. Or if you're running a little bit short on time at this point, you can save a little bit of time by just walking them through it yourself. All right? From there, you're going to segue to this next batch of problems, which is going to cut out, or rather culminate, the math lesson. These are a handful of problems that tend to make students stumped. And you can say, so, the next thing we're going to do here is, I mentioned earlier today that we're going to be teaching you strategies for tackling those problems that tend to make students think, I just don't even know where to begin, which is the 7 words that really should be on this page. I don't even know where to begin. And I want to make sure that when you guys take this test, that you don't get stumped and you know exactly what to do, okay? So let's dive in here. And the very first type of question that we're going to focus on are problems that are actually related to public opinion polls, public opinion poll problems, right? So let's figure this one out here. So give me 1 second here. Just want to make sure that I'm on pacing here. Okay, so the first type of problem, again, that we're going to tackle here are public opinion poll problems. So how many of you guys at school have ever studied the factors that affect public opinion polls? Any of you guys study this at school? Okay, not too many of you guys. So here's the deal. Out of the 58 math questions on the SAT, you'll usually have 2 or 3 questions that ask you about the factors that make public opinion polls either reliable or unreliable, okay? So before we actually dive in and show you an example of an SAT question that's relating to that, I want to talk to you guys about a historical example of one of the biggest blunders in polling history based on a presidential election. So, and what you're going to be doing for these pages is you're going to be doing a lot of paraphrasing. This is something that's not meant to be humorous, but I'll tell you, this to me is something that always gets students' attention. It's a really good historical example that teaches them about, how public polls, the various factors that can really make them unreliable. So you can say to students, I don't know if you guys have studied this at school, if you studied the 1936 election. Does anyone know who FDR was running against? Okay, I see, yes, some of you see it here on this page. FDR was running against a gentleman named Alfred Landon, who had stepped down, who was the governor of Kansas, and stepped down to run against FDR in his bid to be re-elected as U.S. president, right? Now, most of you haven't heard of Alf Landon because we all know that he eventually lost, that FDR won. But believe it or not, every single newspaper actually predicted back in the day that FDR was going to lose to Alf Landon. So here's why. The newspapers, such as the Literary Digest, which was a major, major paper at that time, took public opinion polls, and they polled a few million Americans. But what they did is, where did they get the Americans to poll? They got them from a couple of different sources. They got their Americans from lists of people who had recently bought cars, new car owners, country club members, and people who had recently bought telephones. Remember, this is 1936. Who can tell me here what was going on in the country during the 1930s? What happened in 1929 and what was going on in the country? You're right, Brian. It was 1929 was the stock market crashed. It was the Great Depression, right? So the country was mired, right, in poverty, right? So if I were asking Americans in 1936, and I only asked Americans who were new car owners and country club members, would that be representative of the populace? Of course not. Those people were the ultra wealthy of their day. Those were the 1%ers of the mid 1930s, right? So those people said, hey, we're voting for Alf Landon, which is why all the newspapers thought that he was going to win. In fact, there was only one individual, one person who accurately predicted that FDR was going to win. His name was George Gallup. Any of you ever heard of the Gallup poll? A couple of you, good. Yeah, so George Gallup was then a fairly young pollster, and what he did is he didn't poll millions of Americans, he polled tens of thousands of Americans, a much smaller sample. But the key difference is, when Gallup took his poll, he polled random Americans. He didn't focus on the wealthy, he focused on everyone. He wanted a random sampling. And what he found is that the people he was surveying were going to vote overwhelmingly for FDR. So he was the only one, and that launched his entire career. So what does that prove to us? That proves to us that randomness is the most important factor in public polling. If you don't poll a representative sample, if you do it non-randomly, that can skew the results. And so I want to cut away now and show you some of my discussion about this in the class that I led, and then we'll come back and continue this discussion. So let's cut away and check out that clip. Okay, so you saw that, and now we're going to build on that. And what we're going to do here is we're going to do an example. You're going to use that and bridge that with students to this example on page 302 here. And you're going to do this one. You can do this one together as a class. And you can talk through, and you're almost going to treat this again like a reading comprehension question, even though it isn't, it's a math question, where you want to talk about the answer choices here. So either you or a student can read this one out loud. A researcher conducted a survey to determine whether people in a certain town prefer viewing movies at home or in public movie theaters. The researcher asked 98 people purchasing film tickets in a local movie theater's lobby, and 8 of the people refused to respond. Of the following factors, which makes it least likely that a reliable conclusion can be drawn regarding the movie watching preferences of all people in the town? So let me ask you guys a question before we get to the answer here. Is this truly random? No, why not? You're right, because we're doing it in a movie theater's lobby, right? If I ask people in a movie theater lobby whether they prefer watching movies at home or at movie theaters, why might that not be a great idea to try to uncover people's movie watching preferences? Who can tell me? Ellen, yeah, you're right. Because obviously those people are people who are out at the movies, so they're far more likely to want to go out to the movies rather than like watch Amazon or Hulu or Netflix or what have you, right? So that would bias the results. That would skew the results of that public opinion poll. So I want you guys to bear in mind that location is equally important. It's really, really important where something is conducted. Because if I conduct something in a manner like this question here, I'm going to bias the results. Now, some of you might be thinking choice D. So let's take a look at that. Some of you might be thinking, well, couldn't the number of individuals who refused to respond, there were 8 people, couldn't that skew the results and make it less reliable? I suppose that could, but think about it this way. When these people conduct these polls, they're sitting there with like a clipboard or a tablet and they're trying to get random strangers to answer their questions, right? When you see these people, do you think everyone stops and answers those questions? No, there are a lot of people who probably don't want to be bothered. They just move along. Every single public opinion poll is going to have some people who refuse to respond. So that's never going to be the correct answer. That's going to be a trap answer. The only way that could ever be the correct answer is if it were something like 98 people were surveyed and 92 people refused to respond. Obviously, in that instance, the sample size would be too small to get a valid result, but I've never seen that on the SAT. I've always seen this choice about the number of people who refuse to respond as one of the trap answers, so I want you to bear that in mind. So now that we've talked about public opinion polls, I want to go to another type of question here. And the next type of question, which is related to this, are questions that relate to what we can infer from research survey experiments, okay? Research survey experiments. And we'll do this one again together as a class. You might have 1 or 2 of these also on the SAT's math test. Again, these are obviously no calculator permitted questions because these are testing concepts, right? So could someone read this one out loud for me? Jason, thank you. A research survey was conducted in order to determine if treatment X is successful in stopping hair loss. From a large population of balding middle-aged men, 1,000 participants were selected at random. Okay, good, they were at random. Half of the participants received treatment X, and the other half did not receive treatment X. The resulting data showed the participants who received treatment X had no further hair loss, while those who did not receive treatment X continued to lose their hair. Based on the design and results of the study, which of the following is an appropriate conclusion? So this is almost like a reading comprehension question practically, even though it's a math question. So again, this is building on that, and this is testing what inferences can we draw based on the information, but we want to treat it like a reading comprehension question, even though it's math, and that we want to make sure we're picking something that's precise and that's backed up by the text. We don't want to bring any sort of preconceived ideas to the table here. So let's go one at a time. Let's go A, B, C, D and talk about these answer choices. Who can tell me whether choice A is right or wrong, and if it's wrong, what renders that choice to be incorrect? Jamie, yeah, you're right. It is wrong. And what's wrong with it? Yeah, it's way too broad, right? It says treatment X stops hair loss. Well, maybe, but what about, do we know if treatment X stops hair loss among like elderly people, or maybe someone if they have like a hormonal problem, or maybe some women, sometimes some women will have, a little bit of hair thinning? No, right? We don't know that. We're only talking about who's the subject of this focus group, right? It's balding middle-aged men, right? So choice A is way too broad. That's wrong. Let's go to choice B. You can tell me what you think for that one. Brian again. Good. Okay. Treatment X is likely to halt hair loss among males who are balding. That seems correct, right? Okay. Yeah. No. Well, you're close. I'm glad you picked that because again, I want you to. If you're going to make a mistake, I would far rather you make it in here than on the day of the test. And you're right that it may be more likely to halt it among males. At least it specifies males, but remember, are we talking about all men, like senior citizens, maybe guys in their early 30s who might start balding at an earlier age or 20s even? No, we're talking about middle-aged men. So choice B is getting warmer, but still too broad. Let's go to choice C. Treatment X works better than all other treatments to stop hair loss. Does this mention anything else? Does it mention any other treatments? No, right? Maybe it works better than other treatments, but none of them are mentioned. So the only thing that we can reliably draw here, the only conclusion is choice D. Treatment X is likely to halt hair loss among middle-aged men who are balding, or balding middle-aged men if we want to be more economical, right, with our text. So that, you have to be really careful with these questions. They're almost like reading comprehension questions in disguise, okay? Okay, anyone have an answer for the correct one? Gentleman over there, 100? D. D is correct, excellent. Okay, let's go. So first of all, how many of you guys got D? Okay, good. So really good. Let's talk about why A, B, and C are wrong. Can someone tell me, maybe someone else who hasn't volunteered, can someone tell me why A is incorrect? Go ahead.
It isn't tested anybody other than middle-aged men who are balding.
Exactly. It says treatment X stops hair loss. Seems pretty broad to me, right? We're not mentioning the specific target audience here. Choice B, treatment X is likely to halt hair loss among males who are balding. Well, that could be elderly people or 25-year-olds, right? It doesn't say middle-aged. Do you guys understand how choice B is wrong? Choice C, treatment X works better than all other treatments to stop hair loss. Remember yesterday we talked about answer choices that sound good, might be true, but just aren't mentioned in the passage? Are any other hair loss products mentioned in this passage, in this problem? No. Maybe treatment X works better. Nothing else is mentioned, so I can't make that inference. I can't draw that conclusion. So the only conclusion I can draw here is choice D. So that's an example of the other type of question. So just here's what I want you to bear in mind. Location matters a lot. Sample size matters a lot. Number of people who refuse to respond doesn't matter. There's always going to be a few people who don't respond. Randomness is incredibly important. You've got to have a random sampling of whomever you're polling. And then finally, you cannot make false inferences. Like in other words, you have to think about the problem and say, okay, what is the only conclusion I can draw from this? Not like what might be true, what must be true. Okay. So from there, and by the way, every single thing, this is for you guys as gurus. Again, every single one of these questions has like a strategy recap. You don't have to go through this. You're going to skip this. This is really for your students to check out on their own. So from there, we're going to go to the second type of question here. So now that we talked about some of the factors that can affect public opinion polls and research survey experiments, we're going to transition. Let's go to page 305 here. And we're going to dive into problems that talk about mean and median, and more specifically about the effects of what are known as outliers on mean and median. So before we get to that, let's check out these people here, and let's do a little bit of a refresher on what we mean by mean and median. I know that some of you may not have tackled this at school, and some of you may have done this a while ago, so let's dust off this concept here. Before we even get to these people down here, if I wanted to know their median value, right? What would I do if I want to know the median value for a list of values? What do I do? Who can tell me? Jamie, okay, you're right. Yeah, I can put them in ascending or descending order, right? I can put them in order, and then I can figure out what the middle value is. So let me ask you a question, Jamie. Are these already in order in terms of their income from Jake up to Stephanie? Yeah, they are, right? 55,000, 60, 70, 80, and 85, right? They're already in order. So who would be the middle value? Which person represents the median value here? Somebody else maybe. Monique, yeah, you're right. This one is Kendra, right? Kendra would be the middle value, and she's at 70,000. So that would be the median. Now, using your calculators, who can tell me what the average or the mean value would be for income for these 5 people? Who can tell me? Taylor, yeah, you're right. The average would also be 70,000. So in this instance, the mean and the median are the same. They're both $70,000. Let me ask you a question. Let's change this up a little bit. Let's pretend that instead of Jake here, I'm sorry, Jake, let's pretend, if you guys will flip with me to page 306, let's pretend that Jake, we're going to sub out Jake, and we're going to put in Mark Zuckerberg, the founder of Facebook. Anyone here know how much money Mark Zuckerberg makes in a given year, what his annual salary is? Mark Zuckerberg. And at this point, students will guess all sorts of things. I had a student in the class who guessed like $500,000. And then some students were like, no, it's got to be a lot bigger. It's got to be 200 million, 50 million, a million, whatever. They were guessing all sorts of large numbers, essentially. And you can say to students, believe it or not, even though Mark Zuckerberg is a multi-billionaire worth an estimated, well, the day his company went public, he's worth an estimated 30 billion. I think it's now like $80 billion or something like that. Even though he's a multi-billionaire, he actually only makes $1 per year. That is his annual salary. Mark Zuckerberg, like many other folks in Silicon Valley who work at these prominent tech companies, decide to pay themselves $1 per year. Okay? So let's check it out. Let's go to page 307 now. And now we have Mark Zuckerberg, who may need a benefit for him at some point. He's at $1 per year, and he's followed by Ethel, Kendra, Raj, and Stephanie. So now let me ask you guys a question. What is the median value now that we've subbed in Mark for Jake? Who can tell me? Stacy, yeah, the median is still Kendra at 70,000. So did the median change when we put Mark Zuckerberg in there? No, it didn't. But now you guys can use your calculators. Can someone here tell me what the new mean value is? Charles, yeah. Charles, you're right. It's now just over $59,000, right? Because now we added up $1 plus 60,000, 70,000, 80, 85, divided it by 5, and now it's $59,000 and change, right? So now you can see that by adding what's known as an outlier, the median was not affected, but the average, the mean, was significantly affected. So we're going to get to an SAT problem that tests this concept momentarily, but I want you guys to know, here's what I want you to take away from this. Outliers tend to affect the average of a list of values, whether we're talking about incomes, people's home values, whatever, heights, anything we're talking about. Outliers tend to affect the mean far more than the median. I see we have a question. Jessica, yeah, so you want to know what outliers are? Excellent. So yeah, so outliers are values that are way, way outside the norm. So for example, if I said to you that someone is 6'8", right? If someone were 6'8", that person would probably be an outlier among most adults, right? That's someone who's very, very tall. But if I said to you that an NBA player were 6'8", that person would not be an outlier in that particular sphere because 6'8" happens to be about the average for NBA players, okay? So outlier, whether you're talking about people's heights or income levels or home values or GPAs or what have you, anything that's quantitative, outliers tend to be values that are much smaller or much larger than the norm, okay? That's why they're like outlying, they're outside of things, okay? So let's look at this here, and let's look at a type of question here, and I want to teach you a strategy actually before we get there. Let's go to page 308 here. This is what I want you guys to know. This is very, very important. I want you guys to star this. If the mean value, as it says here, in a group is higher than its median, there have got to be some outliers pulling the mean higher than the median. If the mean is higher than the median, that means there are some outliers that are far greater. And conversely, if the mean value in a group is lower than its median, there have to be one or more small outliers that are pulling the mean down. And I know that's pretty abstract, so let's put this into place and let's check out how that knowledge would help you on an actual SAT question here on page 309. Can someone please read this one out loud? Okay, thank you, Cynthia. So a survey was taken of individual annual income in County Y, and it was found that the mean annual income was $125,000 and the median annual income was $80,000. Which of the following situations could explain the difference between the mean and the median? So even though the word outlier is not here, this is an example of an SAT question testing if you know how outliers affect the mean versus the median. Remember what we said on page 308. Remember what we said. If the mean is far greater than the median, which it is here, 125,000, right? 125,000 is the mean, which is greater than 80,000, which is the median. If that's the case, there have to be some outliers that are far, far bigger, right? So the answer here, who can tell me? Who can tell me what the answer is? Dave, yeah, you're right. This one would be A, right? A few people, at least one person in County Y, has to earn far, far greater annual income than the rest. That's the only way to explain it. Let me ask you guys a question here. What if I changed it? What if I said to you that what if I reversed it? What if I said to you that the median was 125,000 and the mean was 80,000? In that case, the mean is lower than the median. Then what would be the correct answer? Who can tell me? Samantha, yeah, you're right. This one would be B. Great, you guys have nailed it. All right, let's keep going. Now we're going to talk about problems. The next type of problem we're going to talk about, if you guys will flip with me to page 311, we've talked a little bit about big and large values and smaller values. So let's build on that here, and let's talk about certain SAT questions that love to ask you about the least and greatest possible value in a set or a range of values. I'll give you guys about a minute to try this one on your own, and then we're going to review it together as a class. So try this one on your own, and you can use your calculator if you like. Okay, so how many of you guys for this one got choice A? Okay, a lot of you guys, good. How many got B? Show of hands, how many of you guys got C? How many D? No one D? All right, well, believe it or not, D is the correct answer for this question. All right, and let's figure out why here. Let's figure out what's going on with this question, because this question is very much representative of a type of question that you're going to encounter on the SAT, and also the ACT likes these types of questions. So here's the deal. Let me do some mind reading here. Those of you, and I think virtually all of you got A here, what you probably did is you said, okay, I want x times y, to be the very biggest that it can be, the largest, right? So therefore I have to pick the largest possible x and the largest possible y, and I have to multiply them. So the largest possible x is 8, right? Largest possible y is 3. 8 times 3 equals 24, and that's 1/2 of it, right? And that's so far so good. And now I want the least possible value. So I have to take the very smallest that x can be, which is 0, the very smallest that y can be, which is -1, and obviously anything times 0 is 0. So my range is choice A, right? From 0 to 24. Well, here's the thing. Remember, the SAT can be a pretty tricky test, right? It's not that easy. So here's the deal. You're right that the very largest y can be is 24. It's the very largest. But what if I said that x were equal to -8? What if ironically by picking the very, if x were equal to 8, what if ironically by picking the very largest value that x can be and the smallest value that y can be, I actually come up with a value that's even less than 0, right? So 8 times -1 is -8. So the real range here for xy is not from 0 to 24, it's from -8 to 24. That's the correct answer. A is the trap, number one trap. So I want you guys to think here for a second. Let's say that you didn't think of that, right? I know most of you didn't. How could you, strategy-wise, maybe avoid picking A on the actual test? Well, here's the strategy that I would use. If you've got a problem that wants you to figure out the biggest range of something, like, right, the least and the greatest value, one technique you can use is you can say to yourself, okay, I think the answer is 0 to 24 here. Is there any other choice here among the others that has a broader range, that gives me a bigger range? Okay, choice D does, right? It goes from -8 to 24. I still think my answer is A here. Is there any possible value that I can choose for x and y that would enable me to get -8 for x times y? Let me think about that. I can use 8 for x and -1 for y, and in fact that would give me -8. So you'll see here by just considering the other answer choices, and not even all the others, but going automatically, because I don't have to look at B and C. B and C are traps for students. The reason there's 11 here, that's traps for students who do 8 like plus 3 instead of 8 times 3. That's why we have 11. That's not arbitrary. So I don't even have to consider B and C. The only other choice that gives me the biggest possible range is choice D. So sometimes if you're just to make sure that you're right on a problem like this, you want to make sure that if you've got an answer choice that has a bigger possible range, you might want to look to that and just ask yourself, is there anything I could possibly do to yield that range? Maybe the answer is no, in which case your answer is still correct. But maybe it isn't. And that's a really good, what we're doing here is we're giving you a technique to ensure that what you're picking isn't a trap answer. Okay, good. I see that you guys got that. Let's move on here. Let's go to the next value. So this is this is a classic SAT problem in that we're going to talk about here what makes functions undefined. In that this is a classic, more challenging question on the SAT. In that if you don't know what it means to make a function undefined, you can sit there all day and you're still not going to get this question because you just won't know how to solve it. And conversely, if you do know what makes a function undefined, you can checkmate this problem very, very quickly and easily. Can someone tell me here? We've got this function 1 over this somewhat intimidating looking denominator. Can anyone tell me what can I do? What does it mean if a function's undefined? What would that mean about the denominator? Who can tell me? Michael, yeah, you're right. That would mean that the denominator has to be equal to 0, right? That would make the range undefined. It would become like essentially infinite, right? So what would that mean? That means that in order for me to checkmate the problem, whenever you've got an SAT problem that says what value will make a certain function undefined, strategy-wise, what you need to do is you need to take that denominator and set it equal to 0. And you can see here, and now I'm talking to you guys as gurus, all you're going to do with your class is you're going to walk them through this on the whiteboard. And also what you're doing here is you're refreshing foiling, right? First, outer, inner, last, because a lot of students will have forgotten how you take something like x minus 8 squared in parentheses and convert that to x squared minus 16x plus 64. So you may have to refresh with students that FOIL, first, outer, inner, last, is first, the first terms here, so that would be x squared. And then you have outer, so you would go here, minus 8x, and then inner, minus 8x, and then last, right? Which would be minus 8 times minus 8, which is plus 64. Combining like terms, I get this, and that's what we have. That's how we get this portion here, and then I would distribute the 6 here, and that becomes 6x minus 30, and then minus 9, and then I combine like terms, and I get x squared minus 10x plus 25 equals 0. That can become a perfect square. X minus 5 squared equals 0, therefore x equals 5, which is the correct answer. But to me, the real heavy lifting in this problem is not actually, working all of this out. That once you realize that what makes it undefined is setting the denominator equal to 0, then it just becomes a matter of just not making a careless error, honestly. So all you're really teaching students here is the concept of what makes it undefined, okay? From there, you're going to transition, and you're going to go into the next to last problem, and you might want to give students a little bit of the light at the end of the tunnel here. Remember, this is math. Students have done a solid hour 30, hour 35 of math at this point. And so you might want to give them a little bit of a light at the end of the tunnel and say, hey guys, I know that there's a lot of math here today. Stick with me. We are almost wrapped here, just a couple more problems, and then we'll have a really fun diagnostic for you. So just give them a little bit of the light at the end of the tunnel and keep plowing along, all right? And, look, and we'll talk about this in classroom management, but you might want to move around the room a little bit. This problem here, you can tell students that this is a classic type of SAT problem that students look at and they just don't even know where to begin. They start getting really, really daunted by this, right? So we'll read this one out loud, and it reads, a department store gives annual bonuses to its most successful salespersons. Last year, the bonuses were awarded in amounts of $500 or $1,000. If the total amount of bonuses awarded was $38,500 and 56 salespeople received bonuses, either individual bonuses of either $500 or $1,000, how many salespersons received a bonus of $500? And remember, we want to underline that, maybe double underline 500 to make sure that we don't make a mistake. So here's the deal. On the SAT, you'll have one or two questions that are word problems like this. They might be about a restaurant where you have a certain number of tables that can seat 5 people and a certain number of tables that can seat 3 people, and they want to know how many people are sitting at the 5-person tables. Or it might be about a certain amusement ride or movie theater, and it's like, senior citizens get in for $8 and the regular admission is $10. How many senior citizens are there if there's $600 total? So we call these almost like mix and matchy problems because they involve different quantities and amounts of things, okay? And whenever you have one of these problems, your go-to strategy is to set up what's known as a system of equations and use substitution to solve. How many of you guys, by a show of hands at school, have studied systems of equations? Good, a lot of you guys. All right, so let's do this one together. Let's figure this one out. And what you're going to do for your students is you're going to walk them through this step-by-step process here, which I will walk you guys through. So the first thing, and this is a calculator permitted question. So the first thing that we're going to do, we're going to say, we ultimately want to know the number of salespeople who got what? Who can tell me? Dave, you're right. Yeah, we want to know how many people each received a bonus of $500. We don't know that. So I'm going to call that X. I'm going to say X equals $500. Okay? Oh, I'm sorry. X equals the number of people who earned $500 bonus each. Okay? And do we know the number of people who earned $1,000? No, you're right. We don't. So I'm going to say Y equals the number of salespeople who earned $1,000. let's use that, and let's use what we know to try to solve for these unknown values, specifically x, right? We know there are 56 people total, right? So therefore, the number of salespeople who got $500 plus the number who got 1,000 equals 56. Remember, x is the number of people who got 500, y is the number of people who earned 1,000. So therefore, x plus y equals 56 people total, right? We also know that the total amount they earned was 38,500. I'm writing this on the whiteboard. Therefore, 500x plus 1,000y equals 38,500. Jessica, you have a question. How do we get the 500x? Great question. So think of it this way. If I said to you that 10 people each got $100, right? 10 people each got $100. How much money would they have total? Yeah, they'd have $1,000, right? They'd have 10 times 100. Now, in this instance, I know that each of them got $500, but I don't know how many of them there are. But it doesn't matter because I know however many there are, that number of them times 500 each will be the total amount that they earned. Same thing for the 1,000. So that's how I got 500x plus 1,000y equals 38,500. Thank you for that question. Now I can do this two ways. I can either multiply the top equation by negative 1,000 and that'll get rid of the y's, or I can use simple substitution. Remember, I want to solve for x. Why do I want to solve for x? Because x equals the number of people who got $500 each, right? I could have made up any variable. Yeah, I could have said n or p, whatever I wanted. I just chose x, right? So that means that y equals 500 minus x. All I did is I took that and I moved it around, right? Or I'm sorry, I made an error here. Disregard that. That means since x plus y, come on tablet, equals 56, then x equals 56 minus y, which it says here, right? So therefore, I can plug in 56 minus y whenever there's an x, right? Or I'm sorry, you know what? I'm sorry, guys. I haven't had enough caffeine today. I'm saying this to you guys as gurus. Forgive me here, okay? So that means that y equals 56 minus x. That means I can plug in that for the y. So therefore, I can rewrite this equation here as 500x plus 1,000 times 56 minus x instead of the y equals 38,500. I can distribute, solve like terms, all of that, and I'm going to get x equals 35, which is choice D. Now at this point, you can say, and remember, this is a hard, if you start seeing facial reactions like, it seems like students are lost or confused, don't let those students drift off to sea. You can acknowledge that and say, remember, some of these questions are among the most challenging questions on the exam. So if you're someone who might be, thinking I'm a little bit confused by this, that's okay. It might take a little bit of repetition for this to really, sink in here. So let's talk about some other ways to do this. Remember, this is a standardized test, right? They don't know whether you're a math genius and you've been doing system of equations since kindergarten, or you're someone who just guessed right or used even better like an educated guessing process. So what's something we could maybe do here? What's a technique that we could maybe do here if we really wanted to and we had the time to do so? If we weren't running short on time, that could also maybe get us the right answer, right? We could test some of the answer choices, right? We could use guess and check. So we might even want to start like with choice C or B, and if B is too small, we could go up. If C is too big, we could go down. And lo and behold, if you plug in 35 times 500, well, if there's 35 people who get $500, that would mean there's 21 people who got $1,000 because there's 56 people total. So guess and check would be another viable way to do this. But I want to make sure that you guys do know that you could use this, you could solve this using a system of equations. Okay, let's move on. And let's go to page 320, guys. Just two more questions here that we're going to do. So here we see on page 320, we see this nasty looking, we see that we have this stuff that we probably did a while ago, maybe even as far back as middle school, when you guys were learning about fractions and how to clear fractions in the denominator, right? Let me ask you guys a question. We're going to do this one together as a class. Is there a technique that we can use here? Is there a technique that we can use that we learned toward the start of today? What did I tell you guys? What strategy can you use if you got variables in the question, as we do here, we have the variable x, and variables in the answer choices? You're right. I can use plug and chug. I can substitute a value for the variable. Can I substitute like the number 3? No, you're right. Why is that? Chuck? Yeah, because it says x has to be greater than 4. So let's solve this problem together. Instead of doing this one algebraically, which you could do, let's just pretend that x equals 5, right? All I'm going to do is use substitution. So now instead of this, I can do 1 over 5 plus 3. That looks more like an 8. Let's rewrite that. 5 plus 3 plus 1 over 5 plus 4. So now this becomes 1 over 1/8 plus 1/9. And who can tell me, thinking back to whenever you learned about fractions, how could I combine 1/8 and 1/9? What would I have to find? Yeah, I have to find the least common denominator, right? Which would be 72. So therefore, this becomes 1 over 9 over 72 plus 8 over 72, which equals 1 over 17 over 72. And if I've got that, I've got to invert it, and that becomes 72 over 17. Okay? Now I can go A, B, C, D, and figure out which one of those choices equals 72 over 17 when I plug in 5. And let's figure this out. And you can even kind of eyeball this. I mean, A and B have no denominators. They're gone. Choice C and D. Well, remember, x equals 5 here. Does it seem like 2 times 5 plus 7 is going to equal 72? No. This one's going to be D, right? Because x squared is 5, so 25 plus 7 times 5 plus 12 is 60 plus 12 is 72 over 2 times 5 plus 7 equals 17. So that's 72 over 17, right? So choice D is our answer. Now, if you wanted to, you could do this one algebraically. You could find the common multiple, and you could use, you could FOIL things out, like x plus 3 times x plus 4. But remember, I want to make sure that you have different ways to do the problems, and I want you guys to realize just how versatile Plug and Chug is, okay? Let's move on, and again, basically you can more or less, skip this page here, again, as it says here, about Stranger Things. When we were thinking about how to teach students about getting rid of these like ugly stuff in the denominator, we kind of wanted to liken like stuff in the denominator and trying to liberate the denominator, like trying to liberate like Barb from the upside down in Stranger Things. And those of us on the curriculum end really like that because we like to show Stranger Things, but I don't think too many kids are watching that show. Unfortunately, it's more for like 20 and 30 somethings and 40 somethings. So be it. Anyway, from there, you're going to culminate in parabola questions. So let's go to page 326 here. And there's really 2 types of parabola questions you're going to be going over with students. You're going to be going over questions that ask you to put a parabola in vertex form, okay, such as this question here. And the reason we've numbered this one number 30 is that this is an example of the hardest question from an actual SAT. But as it says here in the teacher edition notes, don't do the problem just yet. The first thing you're going to do is you're going to refresh parabolas with your students, and then you're going to come back and do that problem. So first you're going to refresh them. So, what you're going to do here is you're going to use on page 329, and I'll show you in a few minutes how this worked at the class that I led, but you're going to use Justin Bieber's very, very parabola-shaped head to teach students to refresh or teach, depending on what math your students are in, about parabolas and how they shift and shrink, etc. So you can say to students, at Catalyst, we were trying to think of a way to teach you guys about, how parabolas transform, how they shift and shrink, and we're trying to think of something in the natural world that looked parabola-y, that was in a parabola shape, right, sort of like a U shape. And one of us figured out that Justin Bieber happens to have an incredibly parabola-shaped head. Yeah, the Biebs has a very parabola-y head. Okay. So let's use Justin Bieber here. This may, at this point, be all that he's worth. Let's use him to try to figure out how parabolas shift and shrink, okay? So let's all turn, please, to page 330. And before we get to an SAT problem here, let's figure this one out. So the normal equation of a parabola, right? I know some of you know this, is y equals x squared, right? It's kind of in this U shape, right? Y equals x squared, right? With a vertex at 0, 0. Just like Justin Bieber's chin here is at the origin, right? But if I have an equation like y equals x squared, and I put a coefficient in front of it, if I gave you something like y equals, 1/8 x squared, let me ask you a question. Who here can tell me if I put a fraction less than 1 in front of the x squared, how would that change this U shape? How would that change it? Would it make it wider? Would it make it narrower? Jason, yeah, you're right. It would make it wider. Whenever I put a fraction in front of the x squared, a fraction less than 1, it actually makes the shape wider. So bearing that in mind, if we took this, instead of saying y equals Bieber squared, and we said y equals 1/2 Bieber squared, is that going to make Biebs wider? Yeah, it will. It's a fraction, right? So which answer choices can I automatically eliminate because Bieber's head isn't wider? Yeah, I can get rid of choices A and C. Now let me ask you another question. Going back to our original y equals x squared here on the whiteboard, if I said plus 4, what would that do to the shape here, right? If I got x squared here, right, at the origin, and I say plus 4, what would that do? Cindy, yeah, you're right. That would move it up 4 units on the axis, right? The origin, it would go 1, 2, 3, 4. Okay? So analogously here, we're doing y equals Bieber squared, 1/2 Bieber squared plus 2. We know it's not A and C. So which answer choice moves it up? Yeah, choice C, right? That's our correct Bieber, right? What would D be? Let me ask you guys a challenge question. What would D be? What would I have to put there? Yeah, I'd have to make it negative 1/2 Bieber squared, right? Because if I put a negative, it would flip it upside down, right? So that refreshed us a little bit on how parabolas shift and shrink and stretch. Now let's talk about the other type of SAT parabola question you're going to get, which is questions that ask you about putting up an equation of a parabola in vertex form. So we talked about the equation y equals x squared, but sometimes the SAT wants to see it in this format here. The format on page, we're on page 332, guys. Yep, page 332 here. Now, the SAT doesn't give you this formula. You kind of have to know this formula going into the test if you want to get those hardest questions right. By the way, if you do know this formula, these questions are going to be really easy. It's all about knowing it. Just like I said on that undefined function one, the hardest thing about these types of questions is just knowing what we mean by an equation in vertex form. And here's what I want you guys to know. And some of you I know already do know this. When you have a parabola in this form, okay, the h and the k variables represent the vertex of the parabola, with h representing the x-coordinate and and k representing the y-coordinate, okay? So h is the x-coordinate of the vertex, k is the y-coordinate. So for example, before we get to a problem here, if I said to you that there's a parabola with equation y equals 2 in parentheses x plus 3 squared plus 4, what would be the vertex of that? Who can tell me? 3, 4. Close. Okay, you're really close here, but think about it. Look at the equation here. It's not, is h preceded by a plus or a minus sign? Yeah, it's preceded by a minus sign, right? So if this is a plus sign here, that means that the x-coordinate wouldn't be positive 3, it would be negative 3. Okay, yeah, now you guys are seeing it. And now if I gave you negative 5 squared minus 2, y equals x minus 5 in parentheses squared minus 2, what would be the vertex there? Who can tell me? Brenda, yeah, you're right. This one would be 5, negative 2. Good. So let's kind of build on that knowledge and let's tackle this question here. And again, the reason this is number 30 is this was the hardest question on an actual SAT. First thing we're going to talk about is how to do this question in a methodical manner, and then we're going to talk about a really useful shortcut that you can use to crack this question without even lifting your pencil, okay? But first, let's make sure that you guys know how to do this one. So the problem reads, which of the following is an equivalent form of the equation y equals x squared plus 2x minus 3 in the xy plane in which the coordinates of the vertex can be identified as constants in the equation? My God, that sounds really complicated. All that means, though, is that we want to take this equation here, right? We want to take this equation here, and we want to shift it, right, into y equals a times x minus h squared plus k, right? Remember, we can flip back to page, I think 332 was that page? Yeah, 332, and that's our form here, guys. We want it to resemble that. So let's go back here. We have to somehow get this y equals x squared plus 2x minus 3 into this form. Does anyone know a process for doing that? Anyone know? Okay, that's all right. You guys will probably learn this at some point at school. We're going to use a process called completing the square. Again, first we'll do this one kind of the math way, and then we'll talk about a little shortcut for identifying the correct answer, right? So here's the deal. I know that I want this to be transformed into this, all right? So what you want to do is you want to first take out whatever you have the x squared plus 2x, and you want to think to yourself, how could I get x squared plus 2x to be a perfect square? In other words, how could I transform that so that that equaled something x squared here, right? We're going to bring that minus 3 down here. So what I could do here is I recognize that if I do x plus 1 squared, right, and I'll move that minus 3 closer on the whiteboard here. If I do x plus 1 squared, let me ask you a question. If I did x plus 1 squared, what would that equal? That would equal x squared plus 2x plus 1, right? So therefore, I've got here in the original equation x squared plus 2x, so I can bring, that's the equivalent of x plus 1 squared, the quantity. But the thing is, when I do x plus 1 squared, I'm adding a 1, right? Because that's what that would equal. So if I'm adding a 1 here with this, I have to also add a 1 on the left. So this is what it really equals. And remember, I want to get this into this format, right? Into this format. So now I can just minus 1 on both sides, and I get y equals x plus 1 squared minus 4, which is choice D. Now I'm going to talk to you guys as gurus. I realize some of you are probably listening to this video right now and thinking, what the fuck is this guy talking about? Pardon my French. Because a lot of you, like me, are humanities people, people who, took this stuff in high school and then like sprinted as fast as you possibly could toward the liberal arts and never looked back. And that's fine. So I'm bringing that up because if you're struggling with this explanation, please, please, please reach out to us, and we will make sure that when you walk into this boot camp, you do know how to do this. That it's not, because I recognize that for some of you, you haven't done completing the squares since you were 16 or 17 years old. Maybe you never even did it, and that's fine, but I want to make sure that you understand how to do this for your students, okay? So that's just making sure you guys realize that. And then the other thing that I want to mention here, and this is more for students, this is as though I'm talking to you guys as students. So we just did this one mathematically, and yeah, it's complicated. I realize some of you, may not, have done this yet at school. Again, this is a hard question here. But here's the thing. If we know that we ultimately want to get this into a format where it's something like this, something like, right? It resembles this. What is the only answer choice here that remotely resembles that? Yeah, choice D. Choices A, B, and C aren't in that format. So actually, without even lifting my pencil, all I need to do is basically just bubble in choice D, and we can checkmate this problem, right? Now, on the actual SAT, sometimes you'll have one choice that's in this format. Sometimes you'll have two. Generally, you don't have all of them. You can usually eliminate at least two of your answer choices based on knowing that it has to somehow resemble that formula on page 332, right? This formula here. So even if I don't remember how to complete the square, but I know that it's got to resemble it, if I'm talking about the vertex form of a parabola, I can automatically eliminate at least 50% of my answer choices. And again, that's the beauty of a standardized test. And then if you have to guess, and remember there's no penalty for guessing, at least you have a 50-50 shot versus a 1 in 4 shot, okay? Finally, guys, you guys have been really patient. And actually, before we get to that, I want to show you guys a clip of a class just talking about parabolas and Justin Bieber. So let me cut away to that, and then we're going to wrap up this math training video. So let's cut to that class and my talking about Justin Bieber and parabolas. So I want to refresh, before we go into parabola questions in vertex form, which is one type of question that's featured on the SAT, I want to make sure that you guys understand how parabolas shift and shrink. So the general equation y equals x squared, if I graphed it, right, here's my xy coordinate plane, it'd be like that U shape, right? And one thing you have to know is how parabolas shrink and stretch and elongate, etc., right? So when we were thinking here at Catalyst, like how can we explain this to teenagers, we were trying to think of like what's something in nature, it's kind of parabola shaped, and someone recommended or noticed or whatever that Justin Bieber happens to have a very parabola shaped head, which is true. So if you go to page 290 and 291, you can see here on page 290, and this is Justin Bieber's head, that he has actually a very parabola-shaped head with his chin here at the vertex. So here's the deal. Let's say instead of y equals x squared, let's say that I gave you y equals Bieber squared. Okay? So that would result in the original thing, right? It would just be like a Bieber that's like this, right? If instead of that, as it says here on page 291, instead of that, if I change the equation to y equals 1/2 Bieber squared plus 2, let's think about how that transforms that graph, okay? If I put a coefficient that's less than 1, well, actually I have to change that. If I put a coefficient that's a fraction in front of the x, or in this case in front of Bieber, does that make the parabola wider or narrower? What does it do? Do you guys remember from school? If I put a fraction like 1/2, if I gave you, it makes it wider, right? If I say to you y equals x squared, and then I say to you y equals 1/2 x squared, as Zach said, it makes it wider, right? So here, that's going to make the Bieber head wider. What does the plus 2 do? Does that move it left or right, or it moves it up 2 units on the axis, right? So which answer choice here would be correct on that page, page 291, for how Bieber's head would be transformed? It would be choice B, okay? It wouldn't be upside down. What would I have to do to get his head upside down? I'd have to put a negative, right? What would I have to do to get his head narrower?
Have to probably divide by 2.
Yeah. More than one, right? All right, so now that we're back, we're just going to wrap up here. And you're going to wrap up by simply pointing out to students all these formulas that the SAT should give you, but that they don't. And you can show them these pages and encourage them to familiarize themselves with as many formulas as possible. By the way, if they start asking you calculator questions, you don't want to give them misinformation. So the safest answer to that is you want to make sure that you tell students, if you have any questions about the calculator, go to collegeboard.org. They have all the instructions there about what's permitted and what's not permitted. Everything is up to date. So I don't want to give you anything that may not be exactly up to date. So just go right to the source. And if you're taking the ACT, you can go to acttest.org. And that's where you can find what devices are permitted. From there, you're going to give students a math diag. And from there, you're going to take a break. And then you're going to do about an hour and change of the essay. And that's day 2. So that wraps up our math training video. Again, for those of you who are math phobic, please, please, please get a hold of your manager of instruction, and we will do our best to make sure to give you guys one-on-one training for the math portion of the boot camp before you teach.